Have you ever looked up at the night sky and wondered what's out there? What is the universe really like? These questions have puzzled us for as long as we've been able to gaze upon the cosmos. Today, we're going to dive into the depths of these questions, exploring 10 different theories about the structure of the universe, from the cosmological principle that suggests a homogeneous and isotropic universe, to the intriguing idea of fractal structures that propose a universe of repeating patterns. We'll journey through the cosmos and its many mysteries. We'll touch upon the debate of whether the universe is flat, open, or closed, and bring you to the edge of our current understanding. As we embark on this cosmic journey, remember, the universe doesn't just have secrets, it is a secret itself. So let's unravel this celestial enigma together, one theory at a time. Imagine a universe that looks the same, no matter where you stand. This is the idea behind the cosmological principle. Now let's delve a bit deeper into this concept. The cosmological principle is a fundamental notion in cosmology, suggesting that the universe, when viewed at a sufficiently large scale, appears uniform and isotropic. In simpler terms, it's like standing in an endless field of wheat. No matter where you look, the view is pretty much the same, a sea of golden stalks swaying in the wind. This doesn't mean that the universe is featureless or boring, far from it. What it does suggest is a certain level of uniformity on a grand scale. But why is this principle so crucial? Well, it's a cornerstone of the Big Bang Theory and plays a significant role in our understanding of the universe's evolution. If the cosmological principle holds true, it implies that the laws of physics are universal, working the same way here on Earth as they do in the farthest reaches of the cosmos. However, remember, this is still an assumption, a theory. There's much about the universe we don't yet comprehend. Some scientists even propose that the universe might have a fractal structure which could challenge the cosmological principle. The cosmological principle paints a picture of a balanced universe, a cosmic ballet of sorts. It's a testament to the universe's grand design, where chaos and order dance in a never-ending waltz across the cosmic stage. What if the universe were a never-ending pattern, repeating over and over? Imagine a cosmic tapestry where each thread represents a galaxy, a star, a planet, or even a single atom. Now tug at one of these threads and watch as it unravels, revealing smaller and smaller threads, each a mirror image of the whole. This concept, which might seem like a sci-fi plot, is actually a serious scientific hypothesis known as fractal cosmology. Fractal cosmology theorizes that the universe is a large-scale fractal, a mathematical set that exhibits a repeating pattern at every scale. In simpler terms, it's a pattern that repeats itself indefinitely, regardless of how much you zoom in or out. Fascinating, isn't it? This theory shakes the core of our understanding of the universe, challenging the widely accepted cosmological principle, which suggests the universe, on a large enough scale, is homogeneous and isotropic, meaning it's the same in every direction. But fractal cosmology presents a different picture. It proposes a universe that's irregular, infinitely complex, and self-similar across all scales. It's a universe where galaxies cluster into filaments and walls, forming a vast cosmic web. So what does this mean for us? Well, it could redefine how we perceive our place in the universe. It might even change how we approach the mysteries of dark matter and dark energy. In a fractal universe, the cosmos is a cosmic matryoshka with patterns within patterns. Scene script. If you could step outside the universe and look at it, what shape would it take? Unfathomable as it may seem, the cosmos might not be as random as we perceive. The universe, in fact, could take one of three possible shapes: flat, open, or closed. Each shape carries profound implications for the destiny of the universe and our understanding of it. Let's start with a flat universe. Picture a sheet of paper that extends infinitely in all directions. In a flat universe, the rules of Euclidean geometry that we learnt in school hold true. Parallel lines never meet, and the angles of a triangle add up to 180 degrees. But what does a flat universe mean for its fate? It implies that the universe will keep expanding, albeit at a decreasing rate, forever. Now imagine a saddle-shaped universe. This is what we mean by an open universe. In this universe, parallel lines diverge, and the sum of the angles in a triangle is less than 180 degrees. An open universe, driven by its negative curvature, will continue to expand at an accelerating rate, never to slow down. Lastly, picture a closed universe. This is like the surface of a sphere. Parallel lines meet, and the sum of the angles in a triangle is more than 180 degrees. A closed universe, due to its positive curvature, will eventually stop expanding and start contracting, leading to a big crunch, a reverse of the Big Bang. So, is our universe flat, open, or closed? Current observations suggest that our universe is flat, but with the mysteries of dark matter and dark energy yet to be fully unraveled, who knows what secrets the universe still hides? The geometry of the universe holds the key to understanding its past, present, and future. In the grand cosmic puzzle, each piece we fit brings us one step closer to the ultimate truth, the nature of the universe itself. As we continue this quest, let's marvel at the beauty of the cosmos and the mysteries it continues to unfold. What if our universe were just one among an infinite number of universes? Let's dive into this notion by exploring the intriguing theory of the multiverse. So, what exactly is the multiverse theory? Well, it's the fascinating idea that our universe, the one we live in and know, might be just one among many. Yes, you heard that right. There might be multiple or even an infinite number of universes out there. This concept, while it might sound like something straight out of a science fiction novel, is a legitimate scientific theory that's caught the attention of physicists and cosmologists worldwide. Imagine a cosmic landscape, an infinite expanse populated by an endless number of universes, each with its own laws of physics, its own galaxies, stars, and planets. Some might be similar to our own, while others could be entirely different, challenging our very understanding of reality. In this grand scheme, our universe would be just one tiny bubble amid an infinite cosmic ocean. But how did we arrive at such a mind-boggling idea? It stems from the field of quantum mechanics, the study of particles at the smallest scales. Quantum theory tells us that all possible outcomes of a situation do occur, but in different universes. This is known as the many worlds interpretation of quantum mechanics. Take the example of flipping a coin. In our universe, it lands as heads, but in another universe, it lands as tails. Each possible outcome happens, but in separate universes. Extend this concept to all the decisions, events, and interactions happening every moment, and you get an infinite number of universes, the multiverse. While this theory is still highly speculative and we don't have any direct evidence yet, it's a fascinating idea that challenges our perception of reality, offering a new perspective on our place in the cosmic order. In the multiverse, our universe is just a cosmic drop in an infinite ocean of realities. So the next time you gaze at the night sky, remember, there might be countless other universes out there waiting to be discovered. Could our 3D universe be just a holographic projection of a 2D reality? Now, that's an intriguing thought that's been bouncing around in the minds of physicists for a while. This concept is part of a revolutionary idea known as the holographic principle. Imagine a box. Now, think about all the possible events and interactions that could occur within that box. According to the holographic principle, all of these can be described by information imprinted on the surface of the box in 2 dimensions. Mind-boggling, isn't it? This idea was born out of string theory, a theoretical framework that proposes that the fundamental constituents of reality are one-dimensional strings rather than zero-dimensional particles. In fact, the holographic principle is a cornerstone of the mysterious M theory, a theory that seeks to unify all consistent versions of string theory. The holographic principle doesn't just turn our understanding of dimensions on its head. It also has profound implications for black holes. Renowned physicist Stephen Hawking proposed that the information about everything that falls into a black hole is actually stored on its event horizon, the boundary beyond which nothing can escape. This idea aligns perfectly with the holographic principle. But don't worry, this doesn't mean that we're living in a hologram created by some advanced civilization. It's more about how information is stored and processed in the universe. The holographic principle challenges our perception of reality, suggesting that the universe is a cosmic illusion. What if the universe were a vast, interwoven tapestry of quantum loops? A question that leads us into the quantum loop theory, a theory that paints an image of the universe as a grand, intricate weaving of quantum energy loops. The quantum loop theory, born from the fertile minds of physicists, proposes that the very fabric of the universe is made up of these minuscule interwoven loops of quantum energy. Imagine the universe as a cosmic tapestry, with each thread representing a quantum loop. These loops are not just simple circles. They are dynamic, vibrant, and ever-changing entities pulsing with energy. These quantum loops are not isolated phenomena. They interact with each other, intertwining and interconnecting, creating an incredibly complex quantum weave. This weave, this quantum fabric, is what we perceive as reality. It's the stage where galaxies dance, stars ignite, and life unfolds. But here's the twist. These loops don't exist in the 3 dimensions we're familiar with. They exist in the realm of quantum reality, a realm that defies our everyday understanding of space and time. In this realm, the laws of physics as we know them are rewritten, where time can be both a straight line and a circle, where space can be infinite and finite. In a quantum loop universe, reality is a quantum fabric woven by the loom of the cosmos. It's a fascinating theory that challenges our understanding of the universe and invites us to explore the uncharted territories of quantum reality. What if the universe were forever growing, with no end in sight? Picture this scenario, a universe that never stops expanding, never reaches a final size. It's not just a wild thought, but a theory that some cosmologists take very seriously. It's called eternal inflation. Eternal inflation is a concept that stems from the idea of cosmic inflation, the theory that the nascent universe underwent a rapid expansion phase shortly after the Big Bang. But eternal inflation takes it a step further, proposing that this expansion is not a one-time event, but rather a ceaseless process. In this model, the universe we inhabit is just a tiny bubble in a vast cosmic sea. This sea is filled with countless other bubbles, each one an independent universe with its own laws of physics. Our universe is constantly inflating, growing larger and larger at an accelerating pace. And as it expands, new bubbles are created, giving birth to new universes in a process that never ends. But what drives this relentless expansion? The answer lies in the energy of the vacuum of space itself. According to quantum mechanics, even a perfect vacuum isn't empty but seethes with virtual particles popping in and out of existence. This quantum froth can create regions of higher energy that act as the seeds for new universes, triggering more inflation. And what about the fate of our own universe? If eternal inflation is true, then our universe will continue to expand, becoming more and more diluted over time. The stars will drift farther apart, galaxies will become isolated islands in an ever-widening cosmic ocean, and eventually, even atoms could be torn apart by the relentless expansion. Eternal inflation is a mind-boggling concept, challenging our understanding of the cosmos. It paints a picture of a universe that is constantly changing, constantly evolving, and most importantly, never static. It's a concept that reminds us of the infinite possibilities that lie within the fabric of our universe. Eternal inflation paints a picture of a universe that is forever on the move, never to rest. What if the universe were filled with unseen forces, influencing its structure and expansion? Picture this: an invisible hand guiding the cosmos, making galaxies spin faster and the universe expand at an accelerated pace. This is the role of dark matter and dark energy. Dark matter, although unseen, exerts a gravitational pull, binding galaxies together. Scientists deduced its existence from the way galaxies rotate. They spin so fast that without some extra mass holding them together, they would fly apart. This extra mass is what we call dark matter. Then there's dark energy, even more mysterious. It's thought to be a cosmic anti-gravity, pushing galaxies apart, causing the universe to expand faster and faster. It's like a hidden engine, revving up the cosmos. Yet despite their profound effects, we can't see dark matter or dark energy. We can only observe their impact on the universe. Dark matter and dark energy remain the universe's dark secrets, unseen but omnipresent. The universe, it seems, wears many faces. It can be seen as a great leveler, a cosmic equalizer, indifferent to the fleeting lives of celestial bodies. It can reveal itself as a myriad of patterns, echoing the fractal structures we find in nature. It may exist as flat, open, or closed, shaping the fate of all that resides within it. It could be one of many, a single bubble in a frothy ocean of universes. Its dimensions might be more or less than we perceive, possibly even existing in 2 dimensions. It could be a quantum weave, its fabric made up of tiny vibrating strings. Its expansion could be relentless, never ceasing, always pushing the boundaries of what we know. It may harbor dark secrets, unseen and undetected, yet exerting a profound influence on all it encompasses. As we continue to gaze upon the cosmos, we are left to wonder, what is the true face of the universe? Perhaps it's a question that has no single answer. As we journey through these many faces of the universe, we find ourselves entranced by its complexity and beauty. If you've learned something new, if you've felt a spark of curiosity, or if you've marveled at the grandeur of the cosmos, we encourage you to like this video. Your likes help us reach more people and spread the awe-inspiring wonders of the universe. But our journey doesn't end here. The universe is not just for us to observe, but for us to engage with. We invite you to share your thoughts, your questions, your insights in the comments below. What did you find most fascinating? What would you like to explore further? And if you'd like to join us on more cosmic journeys, please don't forget to subscribe and press the bell icon. In doing so, you'll be notified of our latest content, ensuring you never miss an opportunity to delve deeper into the mysteries of the cosmos. This journey is not one to be taken alone. Share this video with your friends and family, inviting them to explore the universe with us, because the universe in all its many faces is a story best shared. Until our next journey, keep gazing at the stars and never stop wondering.